Using the latest CollectionView APIs. First, a self-intro. My name is Joshua Kaplan, and this is my internet handle name. I work as a senior iOS engineer at GMO Pepabo on a product called Minne, the largest handmade marketplace in Japan. My particular interests are tooling, frameworks, and architecture. Also, I'm a stay-at-home Shiba Inu parent of the Shiba Inu picture to the right here, and my pronouns are he, him. Today's topics are thusly: layout, data management and cell configuration, and future directions. Also, I'll be skipping these topics because the surface area of CollectionView APIs is just too large and there's too little time for me to introduce these properly. First, layout. UICollectionView is commonly used to make standard grids like this, complex grids, lists, and more. It manages multiple scrolling views and is high performance and recycles those views just like UITableView does. Meaning that mostly just the views on screen, the cells on screen, are kept in memory, and then it doesn't have, for example, 1,000 cells when you scroll through something. It only has the cells on screen and maybe a small buffer, and then it reuses them. You dequeue those cells and update them accordingly. As far as differences with UITableView goes, the main one is that there can be multiple cells per row. Also, the layout is completely configurable. Class hierarchy is like this. And basically, to make a simple grid, nowadays people would mostly use UICollectionView flow layout or its delegate or interface builder. And this is what the code looks like when defining CollectionView flow layout. It's pretty simple, but about maybe half procedural, half declarative, I'd say. For complex grids, since the iOS 13 SDK, we have UICollectionView compositional layout. It's good for making layouts like this, where you have different types of cell layouts and cells for each section. Commonly seen also on the App Store app, for example. Also, inside the same section, you can have multiple subgroups with different layouts and cell types. At work, I've been using this even on screens with just a simple grid as a way of future-proofing them, because the category of my app is e-commerce, and often there'll be new kinds of things added to that in the future. So it's just often easier just to start with compositional layout. For making a simple grid in compositional layout, it's basically like this. It's similar amount of code to flow layout, maybe a little less. Also, in the iOS 14 SDK, we have the new list style. Essentially, all of the UITableView-like styles are included, and it is part of compositional layout. All of these pictures below are actually UI collection views. To make one, you basically use the list static method on compositional layout, and you pass it a config. Also, it works well with the new cell registration and configuration API, which I will introduce in the second half of this presentation. Now, I also said UICollectionView is completely configurable. And what does that mean? That means that CollectionView is usable not just for grids and lists, but also for 3D stacks, carousels, and many other kinds of layouts as well. For example, this is a spinning type of layout from this open source library. You also have, for example, the Safari tabs, or this carousel style layout, or even this chat message kind of UI that bounces. To make your own custom layout, you can subclass CollectionView Flow Layout or CollectionView Layout itself, and you override specific methods and properties, and the code is procedural and verbose, but it's also very powerful. Also, you can mix it with UIKit dynamics to introduce interactions and movements based on physics without doing every single calculation yourself. Also, if you don't want to define it completely from scratch, there are many open source layouts available, like the ones I introduced. And you could just set those as is as the layout for your collection view, or you can take them and customize them. Here's the code for the layout shown on this slide, and it's probably too small and verbose for you to see. However, you can look at my presentation materials if you're curious. Data management and cell configuration. In the iOS 13 SDK, we got UICollectionView diffable data source, and it fits most cases now for managing data for collection views. Previously, many projects used IGListKit and ARGS data sources, and those libraries provide different diff management, which would free you from having to keep track of different index paths and manage things like animations yourselves, which could be quite error prone and difficult at times. In the iOS 14 SDK, we also got cell and section reordering finally, and we also got the ability to update specific sections. Also in the iOS 15 SDK, there's a new API that allows you to use diffable data source, but also reload data without doing the diff for changes that are extremely large, for example. One minus of diffable data source is that very specific animation behavior can be difficult to implement, which means that it might not be the best choice for those cases. In such cases, you can use ordered collection diffing, a new API in Swift 5.1. Well, I don't know if you call it new anymore. And basically find the sections or items that were inserted, deleted, and moved, and simply call the proper methods inside of perform batch updates, as you did before. The actual code for diffable data sources is fairly simple, essentially getting your collection view and index path and the ID, and then using that to dequeue the proper cell and return it. Also, you create a snapshot and use that to update the data source, choosing whether to animate all the differences or not. In the iOS 14 SDK, we got cell configuration and updating APIs, which are particularly useful for list kind of cells. And they can also work with custom cells. For lists, this is what the code looks like. You create a cell registration with this generic parameter of the list cell, and then also the ID. And then you can take the content configuration or the background configuration and set different properties. Dequeue the cell and set the cell's different properties to customize its appearance. For a completely custom cell, you can take a UI view, conform it to UI content view, make a configuration object like this, conform it to UI content configuration, and you have your cell. However, as you might have noticed, this case, I simply want to make an image. It's some kind of cell with a UI image view. And in that case, and actually many other cases, it seems to me that just making a UI collection view subclass is quicker, less code, and simpler. In cases where you don't need the cell subclass, this is what it would look like to create the registration and then dequeue the cell. Also, in iOS 14 SDK, we have this UI cell configuration state, which represents different states, pre-configured states that the cell can be in: selected, highlighted, disabled. And we can use those states to customize the cell's appearance. However, in the iOS 14 SDK, in order to address many cases, you would have to actually make a subclass of the UI collection view cell, which could be pretty verbose. And at that point, you might as well just not use the API and just start with a UI collection view cell subclass. However, in iOS 15 SDK, we got this configuration update handler, which means you won't need to make a subclass. This API is very useful for lists style cells. For example, if you want to change the disabled state of the cell so that it makes the text gray, you can do it like this. However, for completely custom cells, let's say you have some custom state. For example, the cell is favorited, or it's represent a user who's you're following currently. There's no real way of extending this configuration state. So these new APIs seem mostly useful for lists and not necessarily worth it for custom cells, in my opinion. Okay, future directions. SwiftUI has list and grid, which basically are equivalents of UI table view and UI collection view. However, when it comes to performance, there's not a lot of documentation available, and they both are kind of black boxes in some areas, so it can be difficult to customize the performance. For list, at least internally, it uses UI table view, but grid does not appear to use UI collection view. And because of the lack of information and somewhat lack of APIs and the declarative nature, it can be difficult to do very specific performance improvements. So if you're making a view with infinite scrolling, for example, it might be better to use UI collection view, for example. Also, as far as customizability goes, List in particular didn't have that many customization options until the iOS 15 SDK, which added a lot of options for changing the appearance of the dividers. And also, Grid doesn't have the completely custom layouts and all of the compositional layout style features that you might want. And instead of making those from scratch in SwiftUI, it can be easier just to make something very performant, much easier with UIKit still. Also, if your app doesn't support iOS 13 anymore, if the minimum deployment target is iOS 14, you likely don't need UI table view in most cases. Either SwiftUI's lists or UI collection view can provide for most of your cases. A few cases in which you would maybe want to use UI table view is if there's some kind of very complex customization that you're doing that happens not to be available in either, which is not anything particular I can think of. Or also if you're doing self-sizing cells with dynamic height. Self-sizing cells can be more difficult in collection view. One of the reasons being that collection view cells can have more dynamic width, and if you forget to set that properly, then even if the height should be able to calculate, it sometimes can't calculate. However, if you're doing self-sizing, you might also want to consider SwiftUI as a list as well. In conclusion, you should find the right API for what you're doing. There are a number of new APIs recently, and it's not possible or realistic to memorize how each and every single one works in every little detail. But I think it's very useful to know what APIs are available, and in general, what are the strengths and weaknesses of each API. If you've been developing iOS apps for a long time, you might reach for UI table view right away if you need some kind of list style things. But you should probably get rid of that habit, and you should probably reach for collection view and SwiftUI's list first. Collection view, custom layouts were pushed very hard in WWDC and past ones, but recently they haven't been as much, so many people, I think, have forgotten about just how powerful those custom layouts can be. Also, UICollectionView is very flexible overall with compositional layouts, and the performance is very good. In comparison, SwiftUI's grid views are somewhat lacking, and they don't have all the customization. In the future, I hope SwiftUI gets more of these customization APIs and more, at least, information about how to optimize performance. In conclusion, I hope this presentation has been a good resource about what APIs are out there now. There's so many, this kind of gathers all of the recent changes in one place. And I also hope it provides a good reference when you want to decide which APIs are correct to use. In the final slides, I have links to OSS layouts and collection view libraries. Also a timeline of when APIs were added, so depending on your minimum deployment target, when you can actually use them. And also some different videos and documentation links that I used and referenced when creating this. Thank you for watching my presentation.